5, 4, 3, 2, 1. And as you can see, Cygnus lifting off on top of its Antares rocket on its mission to deliver supplies and science to the International Space Station.
This launch is the first flight of the Antares rocket from Orbital ATK since a tragic flight failure about 2 years ago. The Antares itself is a medium, unmanned orbital rocket meant to launch the Cygnus cargo resupply craft, meant to deliver cargo and science to the International Space Station. More importantly, the Antares craft itself is an orbital rocket. However, getting into orbit is tricky. As a space enthusiast and amateur rocketeer myself, I have had some experience with basic orbital mechanics due to my interests. However, I did not get a true grasp on orbital mechanics until rather recently. Sure, I knew what an orbit was and the very basics of how a spacecraft got into one, but not the specifics of how orbital mechanics work. That is because getting into orbits, as well as understanding how they work, is rather esoteric and complex. However, with the proper application of examples, visual aids, and explanations, orbital mechanics could be understood in some capacity by anyone. Therefore, in this presentation, I shall be demonstrating exactly what an orbit is, the basics of orbital mechanics, the craft that can get there, and how to properly launch said craft into a useful orbit. Before we can talk about getting into an orbit, we have to talk about what an orbit is. According to NASA.gov, an orbit is simply the path of an object moving at such speed that the planet curves away from the object faster than the object can fall towards it. Once an object is moving at such a speed, its motion may be described by the laws of planetary motion laid down by Johannes Kepler. However, when Kepler defined these rules, he did not know how the planets stayed in these fixed paths and followed these rules, only that they did. It was not until Sir Isaac Newton developed his laws of motions, which supported Kepler's laws, that planetary motion was truly understood. Now that the theoretical basis of orbital mechanics have been established, we can move on to the two types of rocket craft at our disposal, sounding rockets and orbital craft. Sounding rockets are rocket craft that follow a simple parabolic arc, straight up into space and straight back down, as demonstrated by this diagram from the European Space Agency. Thus, they are not the craft that we are looking for. Examples of such craft include the A4 ballistic missile and NASA's modern Black Bryant sounding rocket. Orbital rockets are what we are interested in. They are generally much larger vehicles, about the size of a building, and can launch anywhere from a few pounds to payloads the size of a city bus into orbit. Further, the payloads launched by these vehicles can serve as long-term platforms for in-space research and Earth observation, can transmit communication across continents, and can be the starting point for missions to other worlds, whether local or far out. Now that the theory behind orbital mechanics, as well as the vehicles that can take advantage of them, have been established, let's launch into orbit. The launch of an orbital vehicle begins with an initial vertical ascent, so that the rocket can quickly clear the thick lower atmosphere and accelerate all the more efficiently to space. At a certain point into the flight, the rocket will begin a gravity turn, named because unguided rockets perform a similar maneuver that will orient the nose towards the horizon so that it can all the more efficiently begin orbital insertion. Once the main booster has been run out of fuel and has been jettisoned, and the craft itself is above most of the appreciable atmosphere, The booster engines may throttle back or cut off until the craft is close to the highest point, or apoapsis, where it begins accelerating towards the horizon until its periapsis, or lowest point, clears the atmosphere and reaches a desirable altitude. At this point, the craft has inserted itself into a proper orbit. At this point, the spacecraft is in a stable orbit and is released from the upper stage of the launch vehicle. Now that we are here, in orbit around this beautiful planet, let us take a moment to reflect upon how we got here and about the physics that allow us to stay here. As I said before, understanding orbits and orbital mechanics is rather complex and esoteric. However, I hope that I have provided sufficient visual examples and explanations so that you may have at least a little bit better of an understanding of how orbital mechanics work. Now, I realize that this was a lot of information to take in, but orbits are quite literally how the universe goes around. Thank you for watching.